some videos that I sent you guys. I don't know if you guys had an opportunity to watch them. This is exactly what is superheat and subcooling shown on an AC. Let me talk about temperature split. That if someone called me out and said, Richard, my AC is not cooling, and let's just say it's a wall or window unit. Let me get an image of an air conditioner here. Okay, so let's say someone calls me out here and they said, Richard, my AC is not cooling. Now remember, you guys are probably, who's that came in? Wrong button. If I could get this to open, that'd be great. Okay, so I know I'm using these terms that are like confusing you guys. You're hearing subcooling, you're hearing superheat. There's only a very small handful of questions on the EPA about it. But we're talking about the sealed system, and we were talking about undercharges and overcharges and restrictions. And superheat and subcooling is an important part of an air conditioning system and how to measure its efficiency and how well it's working. So I have this air conditioner here, and let me just flip this image the other way. Just, I don't know, for some reason it works better for me. And I'll move it to the center of the screen so you guys can see it. But here's like a wall unit air conditioner. It sticks out the wall, the whole AC. Now, when an air conditioner works, it has an evaporator right here, and the condenser's outside. It has a fan inside of it that circulates this air and that air, but the fan motor has one long shaft. I keep clicking on the wrong link here. Let me show you what an AC fan motor looks like. A wall AC fan motor has got actually two shafts like this here. Okay? And the evaporator fan is on this side and the condenser fan is on the other side. So it's in a wall or window air conditioner, the motor has one long shaft that spins in one direction. And you're like, well, what does that have to do with I'm taking appliance repair? Well, wall and window AC is part of our course. It's one of the last few things you work on as you graduate. And I want to talk about the evaporators here. Right behind it, you have a fan. So it's air is coming in on these coils. Okay? And then it blows them out here. So as it pulls the air in across the evaporator, and the evap is behind these coils right here, as it pulls air in, the coils or the evaporator absorbs the heat from the air and the humidity and then blows it out a little bit cooler and a little bit drier than when it came in. And this is important because I've run across this quite a few times. An air conditioner has a BTU rating. A BTU rating is how much heat will that air conditioner absorb. Let me see, BTU. And it's how much heat it'll absorb. And the thing is that rating is usually per hour, but it could be rated in other things, per minute, per day, per whatever. But British Thermal Unit is the unit of measurement used to measure heat. Okay, and so BTU stands for British Thermal Unit. Okay, but it is important to know this when you're working on a wall and window air conditioner, because when you buy that AC, you have to measure the size of the room, measure how many windows, measure the electronics in the room and how much heat can be produced by those electronics, measure the windows, where the windows on the north or south side of the building, the west side of the building, how much heat is conducted through the window, how much heat directly comes in because the sun's shining in the window, um, how many doors are opened and continuously opened into a space that's air conditioned or non-air conditioned. We have a chart that you use when you get to that portion of the class, and you're to measure a certain room to see how big of an air conditioner does it take to cool that room. And when we talk about wall and window units, we may say um, it may be 18,000 BTUs. It may be 24,000 BTUs. Whatever the number is how much heat can be removed per hour. Um, and 18,000 is pretty good for a small room. My bedroom had only like an 8,000 BTU. It's just when I lived with my parents when I was a kid, it just had a little window unit. 24,000 is pretty big. 18,000 is considered almost a ton and a half because 12,000 BTUs is 1 ton. So how many tons is a 24,000 BTU? Well, if 12,000 is 1 ton, how many tons is a 12,000 BTU?
The 24,000, it would be 2.
It would be 2 tons. Okay, so let's take a let me get one more image here and add this one more image before we move on here. Let's take this wooden match right here. For some reason it didn't copy. Let me do that again. So if we took this wooden match and we lit this match and let it burn all the way down to the end, the amount of heat given off of that match is approximately 1 BTU. Okay? The actual definition is the amount of heat it takes to raise 1 pound of water 1 degree Fahrenheit. So if you had a pot and you put not a gallon, but a pound of water, it weighed 16 ounces, and you put it on a scale or on a stove, I'm sorry, and you measured the temperature, let's just say it's 72 degrees, the water. You turn on the stove and heat up the water. When the water turns from 72 to 73 degrees, that it's equal to 1 BTU. So what does this all have to do with air conditioning, and what does it have to do with our subcooling and superheat? Well, let's talk a little bit more about it. So if one match is equal to 1 BTU, the amount of heat that comes off of a match when you burn it, let's take it. I don't know why this message always pops up when I do it. So let's take a room. Let's just say a room here. And let's fill it up with matches. Let's just say that this room is 80 degrees, right? And if I took this match here, let me see, how do I move this thing? I'll just do it like this. If I take this match here and put it in this room now, it would heat up that room, but not that much, just a single match in a regular bedroom. But if I took 18,000 of these matches and put them in a pile in the floor in the middle of the room and lit them inside this room, Would 18,000 matches heat up that room? Or still
Yeah.
wouldn't make a difference?
No, it wouldn't make a difference.
You don't think it would make a difference?
I say yes, it would make a difference.
Okay, now we're talking about a room not air conditioned. Just the room was 80 degrees. You walked in with a bucket full of matches. There was 18,000 of them. You poured them onto the floor and you lit them. Would it raise the temperature of that room?
Yes.
Yes, it will.
It would. Who knows how hot it would be? It may not turn it to 500 degrees, but it'll raise the temperature of the room. So let's say it was 80 and you lit the matches and now the room is 90 degrees. So if I put 18,000 matches in here and I wanted an air conditioning to cool that room, I put an 18,000 BTU air conditioner in the room and it would take 1 hour to drop the temperature back to the same temperature it was in the room. So what I'm trying to get at is when we're talking about an air conditioner, it has to be sized for the room and the amount of heat that we're trying to remove. So if I lit 18,000 matches and it went from 80 degrees to 90 degrees, the air conditioner, an 18,000 BTU air conditioner, would take 1 hour to get it back down to 80 degrees. Now, what if I had an 18,000 BTU air conditioner and every hour I put 19,000 BTUs of matches in there? What do you think would happen?
It would increase by a degree, maybe.
Well, not that it increased by a degree, but the heat being produced by the matches are larger than the air conditioner is designed to remove. Think of an air conditioner as like a drain pump in a washing machine. And a drain pump can pump out 17 gallons per minute. Okay? Well, if I put 17 gallons per minute into the tub, like I have a hose, what would happen to the water level? It'd never go down. If I put 18 gallons per minute of water into the tub and the pump can only pump out 17, it would rise every minute by 1 gallon of water till eventually it'll flood on the floor. So what I'm getting at is back in the day, air conditioners were a physical size like this one here in the wall. And manufacturers started making air conditioners more energy efficient. And one of the things that made them energy efficient is they made the coils here larger. And they made them more energy efficient. So people would go to the store and they would measure the one in the wall and said, oh, this is 2 feet tall by 3 feet wide. And they'd go to another air conditioner and they'd measure that air conditioner on the shelf. And they said, look, this is 2 feet tall, 2 feet wide. It'll be perfect for this hole. So I take the old one out and throw this new one in. Well, the problem is the 18,000 BTU that was this size, now the energy efficiency changed, and it's now a 12,000 BTU air conditioner for the same physical size. So a customer puts it in thinking, well, it fit perfectly in the hole in the wall, then it's going to do the job. Well, what happened is they put a smaller AC, and that smaller AC cannot remove the heat as fast as everything in that room is applying the heat. So it's what we call undersized. It, like I said, it's an air conditioner acts like a pump that removes heat from the remote room and pushes it outside. So when we're talking about heat and air conditioning and everything else, we're talking about removal of the heat from the room. Now, what if the room called for an 18,000 BTU air conditioner, but we put a 24,000 BTU air conditioner in there? Will that work?
Yeah.
It'll cool it. It'll cool it fast, won't it?
It's
Yeah.
a little bit
Because
faster
it's bigger.
than
Okay, but we have a problem.
what's the problem?
If we use an oversized unit, will have a problem with it. Let me just type what's going on. Okay, part of the rating of the air conditioner is, yes, it's going to remove the heat from the room. And part of the heat in the room is not only the air, but the humidity within that air. If you get a oversized air conditioner, like let's just say, wow, it's 90 degrees outside and the AC in my house really isn't cooling that well, I'm just going to get a bigger unit. Well, what happens if you go too big, the unit shuts off very fast. Instead of it taking an hour to remove that heat, it removes it in 20 minutes. Well, not only does an AC remove heat from the air, it also removes humidity. And if an air conditioner doesn't run long enough, the humidity will collect everywhere in the house and you'll start having mold issues in your vents, molds in the AC unit, because it will not remove the humidity. It'll feel cold, but it'll feel damp and wet. So the size of an air conditioner is really important to the amount of heat coming in, and you want it to remove or just be a little bit over that rating. If I had a 15,000 BTU air conditioner, I'd have to put an 15,000 BTUs of heat measured in the room. I'd have to use an 18,000 BTU air conditioner to cool it, because they don't make a 15,000 BTU AC. Maybe they do. I could be wrong. But anyways, they don't make them every 2,000. You'll find a 6, maybe an 8, 12, 18,000, 24, 32,000. There's only so many sizes. And so if your measurement of the heat in that room is an odd number, you just go to the very next higher number that's cooling size is, and you determine that. So let's go back to the air conditioner. Customer does not agree that they bought the wrong size air conditioner. Even though the last one may have been 18,000 and they put a 12,000 BTU in there, they said, you can't be right, because the AC that was in there before fit in that hole perfectly and this one fits in the hole perfectly. How can you tell me that this AC is not the right size for cooling? So what you got to do then is you got to say, how do I explain it to the customer that that's the wrong size air conditioner? What do you think you would tell the customer? Any thoughts? No? Okay. Customers will never want to agree with you that, oh, I bought the wrong size air conditioner. They're going to say that was the size that's in there and it should cool. So there's two things you could check to see if the AC is cooling properly. What do you do on a refrigerator when the customer calls you out and says the refrigerator's not cooling? What are the things that we want to look at a refrigerator that's not cooling properly?
The evaporator fan.
Check the condenser.
Not the evaporator fan, but you're very close.
The compressor.
No. We want to know if the compressor's on, but I said that it's cooling, but it's just not cooling well.
Condenser fan.
What do you look at inside the refrigerator then?
Frost pattern across the
Frost
evaporator.
pattern. You want to look at the
it's a
frost
defrost
pattern.
issue?
A frost pattern is going to tell you whether the evaporator is full of Freon, right? If you only have frost at the very top of the evaporator, not the bottom of the evaporator is not full. We have a restriction or leak. Hold on one second. My administrator's calling me. Mr. Cutler, I'm in a class with my students. If you click, it beeps and lets me know, and I can let you in. Do you click on the link? You don't need the Google account. Just click on the link, and it tells me you want to come in. Okay, bye. I'm sorry, the administrator, he's going to come in and check out the class. So anyways, what I was saying with the air conditioner is that when you look at a refrigerator, if the customer says it's not cooling properly, you want to look at the evaporator and a frost pattern on the evaporator. If it's got a small white frost on the entire evaporator, it has got the right amount of Freon inside of it. Well, air conditioners don't freeze up. They run their evaporators approximately 36 degrees. Okay? So it's just above freezing the evaporator. Let me just go down here. So this evaporator is running about 36 degrees. So if it's not going to frost, what would you see at about 36 degrees on the evaporator?
Moisture?
Very good. You'd see moisture. It would be cold and wet. Now this is important, and this is what I'm leading up to say, well, okay, well, what do you tell the customer when the customer says it's not cooling? Okay? So you go to the customer, okay, ma'am, I understand that it's not cooling the room properly. I'm going to make these two tests. One of the tests is I'm going to take off this front panel here and look at the evaporator, and I'm going to feel all the loops on the evaporator, the coil loops, and they should have some humidity on them, and they should all be cold to the touch. If some of them are room temperature, we have a Freon problem. Okay? But if they're all cold and wet, that air conditioner is doing its job. The one other thing that we want to do is we want to look for a 15 to 20 degree split across the evaporator coil. What does that mean? We're going to take a pocket thermometer, and let me find one of them online so we can, so you guys can see what I'm talking about. Hold on one second. I'm going to pause this recording for a second. Going back to the pocket thermometer. Let me just get a picture and carry it with me here. So you can have a digital one. You can have this one here. Let me just copy this and put it here. So if you take the thermometer, ooh, it's a big one, isn't it? You take this thermometer and you put it where the air comes in and you measure the temperature. Really what you're going to get is the evaporator inlet temperature, which is pretty much the same as the air in the room. If the room is 80 degrees, you're going to read 80 degrees. Then you want to take this same thermometer and you want to measure the air temperature coming out of the vent, and you should have between 15 and 20 degree split. So what that means is, let's say the air coming in the AC coil is 80 degrees. Okay? The air coming out, should it be colder or warmer?
Colder.
It should be colder. So if I'm looking for a 15 degrees split, it's the same as a 15 degrees difference. What should it read? "65 degrees." So the air coming out of the evaporator should be 15 degrees colder. So if you went to this unit and the customer is telling you, hey, I just bought this AC and this AC is not cooling, right? So you go to that air conditioner and you say, well, ma'am, before I do anything, I'm going to make these two tests. One, I'm going to check the evaporator to see if the evaporator is filled with Freon. How do I do that, ma'am? I'm going to check all the coils to make sure that they're cold to the touch, not room temperature, and they should start collecting humidity. And the evaporator, the whole evaporator, if you put your hand on it, it's going to get wet as it draws the moisture out of the air. Then the next thing you tell the customer is, okay, seeing that the evaporator is full, I know the compressor's pumping and the unit has a proper charge. So it's not a Freon problem. You tell this to the customer before you do anything. And before you tell them it's the wrong size, you tell them, I'm going to check for these things. If I see these things, these are good. Tell the customer, I'm looking for a 15 to 20 degree split across the coil. I'm going to measure the temperature of the air coming in and the temperature air coming out. I do this with the fan motor on the lowest speed. Do you know why I would do it with the fan motor on the lowest speed? Because on the lowest speed gives the air the maximum amount of time to remove the heat. If you're on a high fan speed, it runs so fast across that evaporator coil, it does not have a good time to change temperature. So if we slow the fan down, we're allowing the air just a little bit more time to change from the air coming in to the air coming out. If you could tell the customer these two things before you make the test, and they're allowed to see and touch the evaporator, there you show them the temperature, the air coming in, the temperature coming out, and it met the 15 to 20 degrees, and you told them this is what I'm looking for before I even start, they can't argue with you. You told them this is what a good working air conditioner does. Then the customer's going to say, well, it still ain't cooling. The reason why that's happening, ma'am or sir, is because your unit is not big enough to remove the heat as fast as the heat's coming in. All right? Do you understand those things?
Yeah.
Yeah.
Okay, I don't know if you guys can hear me when I'm talking or not. So I had these videos here. I'm not going to play the videos now, but this one is exactly what is superheat and subcooling. And it's a little bit more information. The guy's actually making the tests on a unit instead of like that picture I showed you. So if you haven't had a chance to watch these videos, watch them after class. There's another video here, troubleshooting with superheat and subcooling. And he has another video here. This is the same guy with a TXV versus a piston. The TXV, we talked about that yesterday, thermostatic expansion valve. There's one right here. That's what it looks like if you look in this picture right to the right of my mouse. It's a valve that senses the temperature of the suction line and opens and closes depending on the amount of superheat in the suction line. If there's excessive superheat, what do you think that means? You could
It's
say,
overcharging. Like
Uh,
there's too much.
actually, superheat is talking about how warm the evaporator or suction line is. Excessive superheat means there's not enough freon in the suction line. You could be a low on charge or a restriction. Too little superheat means the temperature of that suction line is colder, and you may be getting some liquid refrigerant coming back, like we talked about yesterday in that frozen suction line. And that would be an excess of too much refrigerant, a dirty evaporator, or something like that. So you see how superheat plays into restrictions or overcharges? That the expansion valve, it's got a little sensor here on the right-hand side, that shiny part, I can't mouse over it, but it senses that the the suction line's too cold, it closes down and restricts the flow of freon into the evaporator. If it's too warm, the valve opens up. So that acts the same as a capillary tube. The difference is a capillary tube doesn't change how much freon it measures into the evaporator. The expansion valve does. Capillary tube is a fixed ratio. So take a look at these. Even watch this one. Maybe watch one here about the expansion valve and how to diagnose it. But these are terms that you will hear in mainly air conditioning, but they're also used in refrigeration, just not as widely used. So I sent you those videos. So please check them out if you haven't checked them out. Now for tonight's class, what the main reason is I wanted to review the EPA questions that you guys supposedly practiced on Monday. I have not checked your grades yet, but let's go over the answers here because we covered over a lot of this material. Which is the definition of a small appliance? What a bad typo there, that first one. I type so fast sometimes. What do you think the answer is for number one?
Both A and B.
Both A and B. Very good, Greg. That it is manufactured and charged, hermetically sealed from the factory, and it contains 5 pounds or less refrigerant. Number two, refrigerant recovery devices must be equipped with special fittings called, we talked about them. Remember the hoses I showed you with a little handle on them?
Low loss fittings.
Low loss fittings, that is correct. We talked about those yesterday in the Monday with the presentation. Okay, technicians receiving a passing grade on this small appliance examination are certified to recover refrigerant during the maintenance, service, and repair of what?
PTEX, the package terminal air conditioners.
Yeah,
No.
that's the closest thing to a small appliance. This one is MVAC. That's not part of it. This is 10 pounds or more. That's not part of it. And low pressure equipment is type 3, which we'll
That's
talk
the
about when we
refrigerant
get to
question,
it.
right?
I'm sorry?
That's the refrigerant question. I'm sorry, I don't have my glasses on. That's the refrigerant question.
This is EPA. What license do you need to have and what can you work on with that license?
Okay.
Do you know what a PTAC is? Package Terminal Air Conditioner. You see this unit right here?
Yep.
That's a PTAC. It's a package air conditioner. It's all packaged together. And I said at the beginning of this lecture tonight, this is part of our class. This is part of type 1. This is part of appliances. Okay? Persons recovering refrigerant during the maintenance, service, or repair of small appliances must be certified to do what? What certification do you have to work on small appliances?
Type 1 at least.
Type 1 or universal.
Type 1 and universal. In the presentation I showed you, I showed both of those certificates side by side. You need to have type 1 or universal includes type 1, 2, or 3. Number 5, if EPA regulations change after a technician becomes certified, what do you think is the correct answer?
You got to be responsible to comply with
So is that A, B, C, or D?
changes in the law.
That's correct.
That's
It's a technician's responsibility to comply with any changes in the law. Very good. EPA rules require capture of 80% of refrigerant from small appliance sealed system with a non-operating compressor if technicians are using what? Now
Say system dependent.
self-contained.
that's a tricky one. Self-contained is an active recovery, but it depends on how old it is, because if it's made before 1993, you're only required to capture 80%. If it's after, you got to recover 90. So I would say either recovery process,
Okay.
because it doesn't specify there in the date. Okay, small appliance recovery equipment manufactured after November 15, 1993 must be certified capable of what? The key word that we look for in this question, don't even kill yourself, is that we look for not operating compressor, okay? And then we also look for the date, before or after. Before November 15, 1993, it's always 80%.
Yeah.
Whether or not the compressor is working. After, it's 80 with an inoperative compressor and 90 with an operative compressor. So which one of these is the correct answer?
80% of
A.
refrigerant.
90.
90 is if the
Okay.
compressor's working, but the question,
Right.
the answer says what? The compressor's not operating. So it's 80% with an inoperative compressor. Now, this is an old question. Beginning November 14th, 1994, the sale of refrigerants, what do you think will happen?
Limited by law to equipment owners.
No, not equipment owners, but restricted to technicians certified in refrigerant recovery. Does that help you read it, one?
Yeah, that helps a lot.
Okay. So it's if you're not certified, you can't buy Freon. You have to have the certificate. All right. PTAC air conditioners. We talked about them a few minutes ago. May be serviced by Type I technician only if. What's the definition of small
A.
appliance? A. 5 pounds or less of Freon. Okay. Now you need the temperature pressure chart. R22 at 75 degrees is what temperature?
250 psi? No, 130 psi.
At R22 at 75 degrees is about
35.
130. Okay? I'm not going to go over the pressure chart, but that's what that is. You're allowed to use the chart in the test. So learn to use the chart and answer that question. The fountain may be present in refrigerators used in small appliance, campers, or other recreational vehicles and should not be recovered. What do you think the answer is?
All of the
All
above.
of the
All
above.
the above. It could have any of those, and you wouldn't use your recovery machine on any of them, please. Which of the following is or are the reasons to obtain accurate pressure reading of refrigerant inside a cylinder? Remember I said you want to reclaim it, and before you could test it, you have to wait a few minutes for what?
G. And
B.
oh, A and C.
Okay, well, they're going to pressure reading can indicate if there's excessive air or non-condensables in the cylinder. That's true. B, the pressure reading can indicate the remaining capacity. No. Pressure doesn't tell you if you have 5 ounces or 10 ounces. I said that a while ago, that a half-empty tank or a full tank, the pressure will be the same because the pressure is based on temperature. Now, a pressure reading can indicate if the refrigerant has been damaged. Yes. If the refrigerant is damaged, it's not going to match the temperature pressure chart. So for those of you who said both
So
A
B.
and C, that is the correct answer. Now the next question. When installing any type of access fitting onto a sealed system, what should you do?
The system must be pressurized with dry nitrogen before leak testing can be attempted.
Well,
Or-
usually we put an access valve on a system that already has Freon in it, like a bullet
So
valve.
C. So it's C.
The answer is A. The feeding should be leak tested. So if you put a valve on the system, the first thing you want to do is make sure that that valve doesn't leak. Because you don't want to recover Freon if it's leaking because it's going to suck air and moisture into your recovery Freon. Now, which of the following repairs would always be considered a major job? Replace an evaporator coil, replacing a filter dryer, replace a switch, or replace a condenser fan motor?
replacing
A.
a condenser fan motor.
Evaporator coil.
The evaporator coil,
A.
very good. The answer is A, evaporator coil. Now, appliances need to be evacuated all the way to the prescribed level when what?
What happened? Stop?
Well, this isn't like when repair is major, you need to evacuate it all the way to prescribed level. If you're doing a major repair, that is correct, but it doesn't say sealed system. And here, the repair is followed by an evacuation appliance to the environment. Well, you're not going to evacuate the freon to the environment. And leaks in the appliance make it to the prescribed level unattainable. Well, here it's saying appliances need to be evacuated all the way to the prescribed level when you're going to dispose of the appliance. If you're going to throw that appliance away, you got to recover all that refrigerant. Okay? When using a system-dependent or passive, it's like the bag. On operated compressors, what should we do?
Run the appliance compressor and recover the refrigerant from the high side.
Very good, Greg. That is the correct answer. Recover the appliance's compressor for several
You
minutes.
selected the wrong answer, Richard.
Oh. Yeah, it is C. I'm sorry. I didn't read it. I just saw run the appliance compressor. Run the compressor and recover from the high side. You don't want to turn the compressor off. Why is it going to be? It won't allow me to deselect it. Okay. Well, anyways, the answer is this. Run the appliance compressor from the refrigerant. Another typo. My handwriting is so terrible. Okay. A storage cylinder of recovered R500 at normal room temperature, about 75 degrees. You need the temperature pressure chart again. R500 at 75 degrees should be what?
75 PS2.
Nope, 95.
95.
Use the temperature pressure chart for those. Which of the following is not a method or device presently used for monitoring 80% fill? We talked about what? The float device was one of them, right? A scale is another. So we got two left, a sight glass and a thermistor.
Oh.
Thermistor.
Light.
Actually, the answer is sight glass. Thermistors are inside some tanks, and they use a thermistor to measure if it's filled with refrigerant. The following refrigerants used in refrigerators built before 1950 should not be recovered because they may contain what?
All of the above.
All the above.
That is correct. You guys are correct there. Which of the below refrigerants is being considered as a replacement for R12?
R32? Or, I'm sorry, R22?
No, R22 is for air conditioners. What do we use in refrigerators now?
134A.
134A.
This question is so old that you guys haven't even seen an R12 unit. Okay? And now, what is 134A going to be turned into?
R600.
R600. Very good. Now, it's generally recommended that piercing type valves be used on which of the following materials?
Copper.
Both A and B.
Both A and B, copper and aluminum. Most valves won't pierce through a steel pipe, which is usually a condenser. On a sealed system with an operating compressor that has a completely restricted capillary tube, how many access valves are needed to evacuate the refrigerant?
One access valve on the low side and one
on
access
the
valve
low
on the
side
high
of the system.
Yeah, we only need one on the low side, not on the low side, on the high side. Remember, if you're using an operating compressor, we're going to go to the high side, like by the dryer filter, and let that compressor pump the freon out for us or help us achieve the proper recovery. So if the compressor is operating, you only need one access valve, but you need that access valve on the high side of the system. What if the compressor was not working?
So then we would put it on the low side.
Actually, you'd have two valves, one on the low and the high, because the compressor can't help us. All right?
Okay.
How about number
That makes sense.
23? What acids? We've talked about this too.
Sulfuric and phosphoric acids.
Hydrochloric and hydrofluoric acids. Okay? Those are the acids when you heat up refrigerant. When using recovery cylinders equipment with Schrader valves, it's critical to what?
All the above.
All the above. Inspect the valve core for bends or breaks. Replace a damaged Schrader valve core. Cap the ports to prevent accidental depression. Or all the above. The answer is all the above. The last question. Portable refillable tanks or containers used to ship refrigerants obtained with recovery equipment must meet what standard?
DOT.
DOT. All right. These are all stuff we talked about. What did that paper say for